In this video, we're going to talk about annuities. An annuity is when we make deposits at the end of each compounding period. So an annuity is different from the compound interest formula in that when we use the compound interest formula, we are making one deposit at the beginning of the time period. When we have an annuity, instead of that, we are putting money in at regular intervals throughout the time that it is invested. So while we are gaining interest on our investment, we are also increasing the principal amount. So here's my annuity formula. We're going to go through this example problem here. We are starting at age 25 to save for retirement. We're going to deposit $50 at the end of each month into an IRA that pays 5.5% compounded monthly. We want to know how much you will have when you retire at age 65. So I'm going to plug into this formula. 50 is going to be plugged in for P because that's the amount that I am depositing each month. My N is going to be 12 because it's compounded monthly. 5.5% means that my R is going to be 0.055. And T is the time in years. So from age 25 to age 65, that's going to be 40 years. So I will plug in 40 for T. So let me bring up my calculator here. So we are going to have, I'm going to start by putting in my fraction bar because I think that's the easiest way to do this. I'm going to plug in 50 for P, and then I have a double parenthesis that you can see here, and then 1 plus R over N. So 1 plus another fraction bar, and we have 0.055 for R and 12 for N. Then I'm going to close that parenthesis and raise it to the N times T power. So that's going to be 12 times 40. And then in my formula, after I have that exponent, I have a -1 before I close the square bracket, or on my calculator, it's a parenthesis. I'm going to go down here and type -1 and then close parentheses. My denominator is R over N. So go down here, put another fraction bar in, and 0.055 divided by 12 again. And I get my answer of $87,051.98 when I round. So what I'm going to do is I'm going to screenshot that calculation and I'm going to paste it in my notes here, just because I think it's easier to see this way when it's written out in the formula. Question B says how much of that is money that you deposited into the account? And the hint is that you deposited $50 a month for 40 years. So if I deposited $50 a month for 40 years, that means I'm putting in 50 times 12. That's how much money I'm putting in each year, and I'm putting in that amount for 40 years. So 50 times 12 times 40 is going to give me the total amount that I put into the account. On my calculator, I can figure that out. That's going to be $24,000. So of that $87,000, $24,000 is the amount that I actually put in there, and the rest of it is interest. So aside from the amount that you deposited, the rest is interest. So to figure out how much of it is interest earned, I would subtract 87,051.98 minus 24,000. I can do that on my calculator. And I get $63,051.98. So a good portion of that money that I have in that retirement account is from earning interest.